Welcome to Homework Lib.
A bacterial colony grown in a lab is known to double in number in 12 hours. Suppose initially there are 1,000 bacteria present. In part A, we use the exponential function q equals q0 times e to the k times t to determine the value k, which is the growth rate of the bacteria. We round the result to 4 decimal places. And in part B, we determine approximately how long it takes for 200,000 bacteria to grow. So there, the first thing to notice is that for t equals 0, we have 1,000 bacteria present. It means that q at 0, which is equal to q0 e to the k times 0, that is q0 because e to the 0 is 1, is equal to 1000 because it's q at time 0. So q0 is 0. Sorry, q0 is 1000, I meant. That's what I found here. And it means that the function q is equal to 1000 e to the k times t. So that's our first result. And now we know that the bacteria double in number in 12 hours. It means that if we evaluate the function at time 12, and I note that the time is measured here in hours, it's very important. So if we evaluate the function at time 12, we will have the double of the number of bacteria we had initially, that is the double of 1000, that is 2000. So the number of bacteria at time t equal 12 must be 2 times 1000, that is 2000, because it doubles its number after 12 hours. So q of 12, q at time 12 equals 2000, and now we can use the formula of q which we have here at the time being. So it's 1000 e k times 12, because we are evaluating at t equals 12, and that got to be equal to 1000. If we pass 2000 to the left, 1000 to the right, better, we get that e to the 12k equals 2. 2000 over 1000 equal 2. And so we take natural logarithms to find the exponent, that is 12k is equal to the natural logarithm of 2. That's because the natural logarithm is the inverse function of the exponential function. And then k equals natural logarithm of 2 over 12. And if we calculate this value using a calculator and rounding to 4 decimals, we get to 0.0578. Maybe because we have a 0 after the point, it will be maybe better to round to 5 or 6 decimal, but we stick to the statement and we get with 4 decimals. And having this result here, we can say that the exponential function q of t is then 1000 times e to the 0.0578 times t. So we have completely determined the function q using the two informations about the initial number of bacteria present and the behavior of the number of bacteria, that is, that it doubles after 12 hours. So this is part A. Now in part B, we are going to calculate or estimate how long it takes for 200,000 bacteria to grow. And that means that we want to find time corresponding to that number of bacteria. That is, the equation we got to solve is 200,000 equal Q of t equal 1000 e to the 0.0578 t. We got to find time. So again, we do that calculation here by passing this 1000 divided to the left, and we get e to the 0.0578 t is equal to 200. And so taking natural logarithm both sides, we get 0.0578 t is equal to the natural logarithm of 200, and then t is the natural logarithm of 200 over 0.0578. And if we use a calculator, this is approximately equal to 91.666. So this is given in hours. So to have a better idea, we divide that by 24. We have that goes to 3, and then the remainder to get the number 91.666 is about 20 hours. So it's almost 4 days. So the time required for the bacteria for let's put the number better first. For 200,000 bacteria to grow, the required time, I meant, for 200,000 bacteria to grow is about 3 days, because 24 times 3 is 72 hours. It's not 4 because times 4 is 96. It's greater than that. So it's 3 days, and the remainder, which is 91.666 minus 24 times 3, is 20, almost 20. So it's 3 days and 20 hours. That's the time required for the bacteria to grow to the number 200,000, or equivalently to have in the colony in the lab to have 200,000 bacteria. And the information comes from the fact we are using an exponential function of the form q0 times exponential of kt with the growth rate of k, and that value k is determined by knowing the behavior of the bacteria, that is, that it doubles in number in 12 hours, and that initially we had 1000 bacteria. With all that information, we determine completely the function q, including the rate of growth of the bacteria, and we found the time required for the bacteria to grow to a number of 200,000.